In this lesson, we have the classic battle of irrational versus rational! Sorry, got carried away there for a second. But in this lesson, we are going to talk about the definition of irrational numbers and rational numbers, and we're going to practice identifying which ones are rational and which ones are irrational. Rational numbers are those that can be expressed in the form of x over y, where both numerator and denominators are integers. Nice, normal, rational numbers. The key word here is ratio. It can be written as a ratio. Irrational numbers are, well, they're not rational. That's what that prefix means, is not written as a ratio. Literally what that word means. They cannot be expressed as the form of x over y. And you can usually identify an irrational number because it's a decimal that does not terminate, doesn't stop, it goes on forever, and it doesn't fall into a repeating pattern. So if it repeats, it ends up being 0.333333 repeating, that is actually a rational number. If it doesn't repeat, but it does go on forever, so maybe it's 0.2467, 9326468 910. Anyway, that's irrational, and we're going to look at a couple of different examples here. All right, so whether these are irrational or rational. So first we start with the number 5. So can 5 be written as a ratio of integers? It can. 5 over 1 is the same thing as 5. And so that makes it a rational number. How about 1/2? Well, it's already a ratio of two numbers. Rational number. If you turn it into a decimal, you get 0.5. Not a decimal that goes on forever. It's just fine. Negative 3.14. Can we turn this into a fraction? Well, let's see what my calculator does. Negative 3.14. Math frac. Enter. Oh, it is a fraction. I can write that as a fraction. Negative 157 divided by 50 is negative 3.14. So that is a rational number. Now, you might have heard that pi is irrational, and it is. If I enter pi on my calculator, you get 3.141592654, and it truncates at 4 or rounds to 4, but there's actually a whole lot more decimals. Your calculator just only displays this many digits. But the number just 3.14 is rational. Pi is irrational. All right, let's take a look at the square root of 5. So we're looking for a number that times itself gives you 5. Well, 2 times 2 is 4, and 3 times 3 is 9, and we skipped right over it. So I bet it's a decimal, and in fact, it is a decimal that goes on forever, and it looks like it starts to repeat, but it doesn't really. So that makes this one an irrational number. He's our first irrational number. And then the square root of 9 is 3, because 3 times 3 is 9, and I can write 3 as 3 over 1. So that's a rational number. So any number that you can turn into a fraction is a rational number. Any number that you can't turn into a fraction is an irrational number. And you'll know them also because they will be decimals that go on forever and never fall into a repeating pattern.